Let's talk about the weather, specifically the rather dramatic sort. A hurricane is a very big, very cross storm. It starts its life out over a warm bit of ocean. Imagine a spinning top, but one that's hundreds of miles wide and made of wind and rain. This spinning mass of fury has ferocious winds, torrential rain, and it builds up enormous waves. When one of these makes landfall, it can be very destructive. It can flatten buildings, flood entire towns, and generally cause a great deal of trouble for everyone involved. And lately, there's been a lot of chin-stroking and head-scratching about a rather pressing question. Are these things getting worse? Yes, they are. The reason this matters is that the pattern is becoming clearer. It's not just a one-off, a bit of bad luck. Scientists have been looking at the data for years. They've noticed a trend. The hurricanes we're seeing now are packing a bigger punch than the ones our grandparents remember. They are more intense. And since these storms affect millions of people, from the Caribbean to the coast of America and beyond, understanding why they're getting angrier is, to put it mildly, quite important for our future. It's not just about a bit of a breeze. It's about safety and survival. So, what exactly is happening? It's not that the planet has suddenly decided to be more moody. The changes are gradual, but they are significant. It's a global headache. The first and most important piece of the puzzle is the sea. A hurricane is, in essence, a giant heat engine. It gets its power, its oomph, from warm ocean water. It draws up heat and moisture from the surface of the sea, and this is what fuels its spinning winds. Now, if you want to make an engine more powerful, what do? You give it more fuel, or a higher quality of fuel. In this case, the fuel is warm water. And the simple fact is, our oceans are getting warmer. It's a bit like leaving the stove on under a pan of water. It just keeps getting hotter. This warming isn't a mystery. The main cause is the blanket of greenhouse gases we've been pumping into the atmosphere. This blanket traps heat from the sun, and a huge amount of that trapped heat, over 90%, has been absorbed by the oceans. The effect is straightforward. A warmer ocean provides a much more potent source of energy for a developing storm. A storm that forms over water, that is 1 or 2 degrees warmer than it used to be, can become significantly more powerful. It's a direct cause and effect relationship. Warmer sea means more fuel, and more fuel means a stronger hurricane. Let's look at a simple fact about this. Sea surface temperatures have been rising steadily for decades. The top few meters of the ocean have absorbed as much heat in the last 50 years as the entire atmosphere. This isn't a small change. It means that when a storm system does start to form, it has a deep reservoir of high-octane fuel to draw from. Next up, we have the issue of water. Not just the water in the sea, but the water in the air. There's a basic bit of physics at play here. Warmer air can hold more moisture. For every 1 degree Celsius of warming, the atmosphere can hold about 7% more water vapor. The sea is getting warmer, the air above it is getting warmer. When a hurricane forms over this warmer ocean, it's not just sucking up heat, it's gathering a staggering amount of moisture. It becomes a massive airborne sponge. The effect of all this extra moisture is more rain, a lot more rain. When the storm moves over land, it unloads that colossal amount of water. That's why we're seeing catastrophic flooding. The damage isn't just from the wind, it's from the sheer volume of water dumped in a short time. Recent major hurricanes have produced rainfall totals that shattered previous records. The storm becomes a deluge, turning streets into rivers and overwhelming storm drains. Worse, there's evidence hurricanes are slowing down. Their forward speed across the map has decreased in recent decades. Scientists link this to a general slowing of atmospheric circulation, which is tied to Arctic warming and ice loss. A slower moving storm is a terrible thing. It lingers over one area for longer. Instead of passing in hours, it can hover for a day or more, dumping all that extra moisture in one spot. This is a genuine double whammy. A storm carrying more water than ever and moving more slowly, giving it more time to release that water. The perfect recipe for devastating floods. Another critical factor is the sea level itself. It's rising. This is happening for two main reasons, both linked to a warming planet. First, as the vast ice sheets in Greenland melt, Antarctica melts, and that water runs into the sea. Second, as the ocean water itself gets warmer, it expands, a process called thermal expansion. It's like the liquid in a thermometer. When it gets hot, it takes up more space. A simple fact is that global mean sea level has risen by about 20 centimeters since 1900, and the rate of that rise is accelerating. This might not sound like much, but it has a profound effect during a storm. The most dangerous part of a hurricane for a coastal community is often the storm surge. This isn't a normal wave. It's a massive dome of water that the storm's winds push ahead of it towards the shore. It acts like a temporary, localized tsunami. Now, if the baseline sea level is already higher, that storm surge has a head start. A surge that might have once been stopped by a seawall or a dune can now push right over it. It allows the flooding to penetrate much further inland, inundating areas that were previously considered safe. Every centimeter of sea level rise makes that surge more destructive. As we've seen, warmer oceans are breeding stronger storms with higher maximum wind speeds. So not only is the launch platform for the surge, the sea level, higher, but the force creating the surge, the wind, is also greater. So to sum it all up, it's a fairly straightforward, if rather grim, chain of events. A warmer world caused by our activities is making hurricanes more dangerous. The oceans are hotter, which acts as high-octane fuel to create stronger storms with more powerful winds. The warmer air holds more moisture, which means these storms can dump a phenomenal amount of rain, leading to terrible floods. The sea level is higher, giving the storm surge a leg up to push farther inland. And to top it all off, the storms themselves might be moving more slowly, allowing them to batter a single location for longer. It's a whole package of bad news. This isn't just a theory or a wild guess. This is what the vast majority of climate scientists and meteorologists are observing. They all point the same way. The rules governing these storms are changing with a warming planet. Ignoring this would be like ignoring a rattling noise in your engine. It will probably be fine for a bit, but eventually it's going to lead to a very big, very expensive problem. We have to acknowledge the link. Now, it's easy to feel a bit hopeless. These are enormous planetary-scale forces at work. But we shouldn't throw our hands up in despair. There are two clear paths of action. First, adapt. Build stronger, more resilient coastal communities, better sea defenses, improved drainage systems, restore natural barriers and wetlands, prepare robust evacuation plans. Preparations must grow to meet the threat. Second, tackle the root cause. Reduce the emissions warming our planet. Transition away from fossil fuels, solar power, wind power. Thank you for watching. Please like and subscribe.